Continue with example 2. Solve a system of linear inequalities. Malcolm earns $20 per hour mowing lawns and $10 per hour walking dogs. His goal is to earn at least $200 each week, but he can work a maximum of 20 hours per week. Malcolm must spend at least 5 hours per week walking his neighbor's dogs. For how many hours should Malcolm work at each job in order to meet his goals? So how many jobs does he have? He has 2 jobs here, right? First one, he's gonna mow lawns. And then the second one, he's gonna walk dogs. Mowing lawns would be more expensive. Every hour he would earn $20. Walking dogs, he earns $10, right? He wants to earn at least $200 each week. He can only work maximum of 20 hours. So let's think about how we can write this as inequalities, systems of inequalities. We know that it's not going to be equations, but it's inequalities by looking at these words, at least, right? So it could be anything more than 200. He wants to earn more than or equal to 200, okay? And then maximum of 20 hours. So maximum means, is 20 is 20 hours also okay? Yeah, so at most he will get 20. So he wants to work less. If he works a little bit more than 20 hours, that's not okay. So we're going to write inequalities using that, okay? And we're going to set variables. So step 1, define the variables. X is going to represent the number of hours spent mowing lawns. Y is going to represent number of hours spent walking dogs. So they both represent the number of hours because we want to know how many hours should he work for each job. Step 2, write inequalities to model the constraints. So first, we can write the first inequality by looking at the rates, right? $20 per hour for mowing lawns. So if you have 1 hour for X, you earn 20. So you can say 20X. If you work 1 hour for walking dogs, so that would be $10. And then how many hours you spend walking dogs would give you 10 times Y. So that's 10Y. So if you add them, you get the total cost, right? Total earning is this. And you want the total earning to be greater than or equal to $200. So this equation is all in terms of dollars, but using the variable of hours. Okay? So the second one now, we don't want him to work more than 20 hours. So X, the number of hours he lawns, and Y, the number of hours he spends walking dogs. If you add them, that's the number of hours, and that should be less than or equal to 20. Okay, now we have an equation with hours. It's okay if the equation means different things. Like the first equation represents dollars, the second equation represents hours. As long as you match all the terms in one equation or one inequalities to have the same units, that's fine. And now we want him to spend at least 5 hours walking dogs. So hours for dogs would be Y. So we want Y to be greater than or equal to 5. Okay, so we have 3 inequalities for our restraints, our conditions. And now step 3, we could solve for the inequalities. For inequalities, it's the best to use graphing. So we're gonna graph all these inequalities at once. And if we look at them, the first one, Y has to be greater than or equal to 20 minus 2X. That's this red line. And so it's greater, so you color above here, right? And then the blue line is 20 minus x, and y has to be less than that. So you color downwards, and then your y has to be greater than equal to 5. So anything greater than equal to 5 over here, right? So the only overlapping area is this one. Any point in this area would work, okay? So we have a lot of points, but the entire area, the triangle area here, would be our solution, okay? It needs to be an area of solution for inequalities. So for example, 12,7 is in our triangle, so it works, okay? It's one of the solution. You can also have a, 8, a, 12. You can have 4, 14. So any point in this area would be your solution, okay? Let's look at try number 2. See if you can sketch the graph of this system of inequalities, and then figure out all set of points that will be the solution for these inequalities. And if you have more time, please give some examples of points that will work. So pause the video, see if you can figure out the solution by yourself. See if you can graph it by yourself. If not, you need to go back and study graphing inequalities first. That should be from Algebra 1. If you want to check answers, you can use graphing technology to check your answers. So pause the video and come back when you're ready for answers. Okay, are you ready? Okay, so you need to know how to graph them. First, you're going to change these into slope-intercept form, right? So y is less than equal to negative 2x plus 14, and then you have y is less than equal to negative 1 over 2x plus 5. And then you graph these equations, and they're all solid lines because they're less than equal to, right? And then you color downwards for these lines, from these lines. And then you have x greater than equal to 0, y is greater than equal to 0, okay? So we can check using graphing technology. So 2x plus y less than equal to 14. Like I said, you have to solve for the slope-intercept form first, so you know how to graph them. And so you have 14 as your y-intercept, and then negative 2x. And then the second equation, x plus 2y less than or equal to 10. So you have 5 as your y-intercept, and then minus 1 over 2 as your slope. And then you have x is greater than or equal to 0. So x equals 0 is this vertical line, and then everything greater than that for x would be on the right. Y is greater than or equal to 0 would be the horizontal line, y equals 0, and then everything greater than 0 for y would be above. So you see that the overlapping area is this quadrilateral here, right? So if you were to give a point that would work, that would be part of your solution, could be 5, 1, 4, 1, 4, 2 also works, 4, 3 also works because that's a solid line. And then 2, 1, 2, 1.5, 2, 2. All these points in this area works. Okay? So, yeah, that should be your solution. Or that was example 2.